I want to talk about static in a little bit more in-depth way and more subatomically how it is created and why it is a very interesting concept in the paranormal. So we have a lot of equipment in the paranormal that can detect certain things and barometric pressure and all of these things. And I think that a lot of these sciencey words are thrown around, but we don't really have even sometimes a general idea of what some of these things are actually looking for and why are we looking for those things in the paranormal. So we can have a general idea of why we look for EMF because, maybe since humans emit EMF, there's a possibility that if we believe that spirits are the deceased energy of humans, that maybe they will also emit EMF. And there's sort of all of these different ways that we can sort of look at this. Like, what are some other ways that we can, let's see, what are some other sort of indicators that we use? We do have things that I want to say it's called the Chattergeist, which measures like air pressure and temperature and all of these things. Like, what is the theory behind why there are temperature changes? And that's another live that I think that we'll do when we talk about temperature changes, because it's like, why does spirit presence drop the temperature? Does it have to do with air pressure? Does it have to do with soaking up energy in there? Yeah, there's all sorts of things. So today I wanted to dive deeply into static, how static is generated, how it's made on a subatomic level, and why it is a really cool theory to apply that to paranormal instances. Because we have these experiences where we will get the goosebumps on our arms, or we feel that ambient static. We feel our hair lifting up. We feel the hair on our arms lifting up. And sometimes that can be this visceral emotional reaction, a fight or flight response, or sometimes it is described as that feeling of static. And if we think about generally how some ways that we can create static. So I have my Van de Graaff generator, and this is a manual static generator. But some ways that we know in the real world that we create static are things like walking across a carpet can create static. Rubbing a balloon on your head can create static. Brushing your hair with like a boar's hair brush can create static. But what is happening when that static is being created? And why is it really interesting and a thing that maybe we can keep an eye on when it comes to our more tinfoil hat moments? So let's dive into that. Okay, so we know that static, you need to have some sort of movement in order to generate that static, because we have to have that transfer of electrons in order to create static. So if I take my Van de Graaff generator and there is a manual, here, we'll turn this around so it's a little bit more like interactive so you can see it happening. And we turn this crank. What is happening here is there is this rubber belt, and rubber is really susceptible to creating static. And then we have this metal globe up top, which is a conductor. So that's going to be able to soak up all of the electrons that are being transferred into here. And then this discharge ball is what is going to transfer that electron imbalance and create that little spark that we see when we discharge onto a conductor. So I'm going to manually turn this crank, and oh yes, you can. So you can see this belt start to move. And there's a little comb down here that's also, I just shocked myself, that's also made of like a plastic substance coated in a metal. And when that happens, let's see if we can see it on Facebook. So right here, if I were to slow this down, it would be so much cooler. You can see, come on Lauren, get with it. You can see, let's turn off this light behind here. And, oh yeah, I bet you will be able to see it now. Okay, so you'll be able to see. No, still not. All right, you're just going to have to trust me on that. Can you hear it, though? I know. Oh, did you see that one, though? So we know that you know, happens. And we generally know, you know, friction creates static in certain situations. And one of the most, I know, one of the most, the ways that we all can witness this on a nature scale, out in nature, other than, because, you know, carpet is not a natural substance. So us, you know, rubbing around on a carpet is not something that naturally occurs in nature. But where do we see this in nature? We see it in lightning. So what is happening in these clouds is still the environment that harbors lightning within a storm cloud is something that currently we're not able to explain using science, which I think is really, really cool, because it sort of gives you that sense of wonder that we still have so much left to explain. And I'm not using that as, you know, an appeal to mystery fallacy where I'm saying like, oh, you know, we can't explain that yet, so ghosts must be real. That's not what I'm saying. That is called an appeal to mystery or an appeal to ignorance fallacy. So now lightning occurs in two different ways. Lightning occurs within a cloud, where a lightning bolt transfers to another cloud within the clouds. That's when we see those clouds light up really, really bright, but we don't actually see a discharge to the ground. And then we have the big lightning strike that hits the ground. And so lightning occurs thousands and thousands and thousands of times per minute. Somewhere on Earth, lightning is striking now, 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 now. So we have those two different instances, lightning striking inside of a cloud and then lightning discharging onto the earth. Those two different instances are also two different kinds of charge, positive charge and negative charge. So when you are creating the static, when you are the one creating it, or when that static is just being kept into the big storm cloud right here. Let's pretend like this big discharge ball, this big ball on the part of my Van de Graaff that is creating the static, let's pretend like this is the storm cloud. And then we're going to pretend like this is the earth. So when this is generating all of that static, if we were to move the discharge bulb away, and then this is not going to be able to discharge right away. So if we're able to move this away, all that static that is being generated inside of this ball you're probably not hearing that. So it's like little tiny clicks of discharge. Those are the lightning strikes that are happening inside of the clouds. And though that is a negative charge right now. The earth, when it discharges, it's a positive charge. So why is that important? We're going to talk about why that's important, and we're going to talk about why that happens and how that happens. So let's talk about how a positive charge and a negative charge differ on a subatomic level. So we all know what atoms are, right? A-T-O-M-S. So we know where are atoms? Where are they? I'm going to let the comment section catch up. Where are atoms? I'm going to give you a hint. Like Kimmel. Oh, no, not Kimmel. No, his name is spelled B-I-T-C-H. I'm going to record that and I'm going to send that to him. So atoms are everywhere. Like I'm waving my hand through particles and atoms right now. And I'm like hitting some atoms. And I'm picking up some atoms. And I'm about to drink some atoms. Atoms are this everywhere. Absolutely everywhere. And this is going to be a really we're gonna put up our little whiteboard, and we're gonna pretend like this is a really cool picture of an atom. Okay, here's my atom. So atoms are everywhere. And then, how did you get? Doopy-dop, doop-doop-a-doop-dop. So inside, do we all generally remember the makeup of an atom? The atom? What is the heart of an atom? Oh yeah, a bunch of atoms writing with atoms onto some atoms. Yes. So atoms have a smaller there. So everything is made up of these, but also what makes up an atom? So atoms have what's called a nucleus, which I think we all know. Yes, exactly. Good job. So this is our nucleus. This is our nuke. And inside that nucleus, we have protons and neutrons. So we have our protons, we're going to call those P's, and those are a positive charge. Neutrons, however, they have a neutral charge. So they're like a net zero. So protons are like a positive. So we're going to put +1 there. Can we see that? Yeah, you guys can see this. And then neutrons are going to be they're like a plus or minus 0, because they're just a neutral. And then, so when I'm talking about static, and if you've heard me really go on a rant about static, I'm talking a lot. Oh my gosh, you absolutely do win, because anytime I talk about atoms, and especially if I talk about nucleuses, all I want to say is, oh, hey Kalani, well look, welcome back. But we're talking about static. Mitochondria is the powerhouse of the cell. Jordan wins. So, but around this nucleus, so we have our positive and our neutral, but around the nucleus is the secret to static. It's our electrons. So our electrons are all around. So we're only going to do 3 electrons because I can only really fit 2 more protons in there. So now there's a lot more for this. Time for a refresh. So we have our positive protons, we have our negative electrons, and your electrons are what get, they're very finicky things. So I like to say that I really identify with electrons. They're just kind of like back and forth, they're really excitable, they're all over the place, they like to travel, they like to really sort of like make your hair stand on end. I just really love a good electron. And because these finicky little electrons are so volatile, when you rub past an atom with friction, right? Some of those electrons will transfer. So some of those electrons will leave this atom. They'll leave it. And they'll transfer onto the atoms of something else. So then that's leaving this with a positive net charge. So less electrons means that it has this positive net charge. And then this will have a negative net charge. So if I'm rubbing across carpet, they're ADHD. Yeah, seriously. Yeah. That's why they're my favorite. I love them. So if I'm rubbing around on the carpet, I'm picking up all these electrons from the carpet, right? And then I become a negatively charged person. And it does happen with everything, but we have it happen the most on things like the rug or a balloon or a rip in space-time. But anyway, so I become, drier environments, you become way more susceptible to that electron imbalance. So, yes, please lurk, Brandon. And I'm not even talking. Oh man, I don't even have. I have a whole thing of spiders right here. Not real ones, but like my decorations. So when I'm rubbing around on the rug and I'm picking up all those extra electrons, I become negatively charged. And then when hi Candy, and then when I touch something that is like a conductor, like a piece of metal, or like our discharge globe, or the earth is one big conductor. It's a ton of water, and it's a big, huge conductor. That's why we see a lot of lightning strike over the, well, not really so much over the ocean, but the ocean basically is like one big battery with saline. But when I touch something to discharge, all of those extra electrons that I've picked up now all transfer onto that other piece, not necessarily making it negatively charged, because usually it just grounds out onto the ground and it just becomes neutral again. And then I become neutral again. I'm good to go. So now the carpet, because I took its electrons, now it has this positive charge, and it usually transfers back on again just naturally, picks up everything again, because it pulls back into well, Lake Erie is it's not a body of salt water, but yes, like Lake Erie, lightning strikes all over big bodies of water. That's super, super natural. And the earth is made up of what? Like 70 or 80% water? So lightning strike all over the world. Between now and like 5 seconds ago, lightning has struck like 2,500 times. Probably more than that, 250,000 times. So I digress. So now we know what happens inside of the atom and this electron exchange that happens when static is occurring. So to break it down really, really simple, we are going to go back to our Van de Graaff generator, and we are going to now imagine what's happening with the electrons. So we're going to be taking the electrons from this small plate down here with our rubber belt, and those electrons are going to collect into our rain cloud. And then our discharge ball, or our earth, or person, you know, however lucky you're feeling, will balance out those electrons again. So we're creating static up in our rain cloud. So now our rain cloud is becoming negatively charged. And then when we discharge it, it's a positive charge again. Negative, happening, 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 positive. So here's the cool thing about the positive and the negative charge. The negative charge is that buildup of static. It's what you feel. It's what makes your hair stand up. It's what that like dry environment and everything's like sticking to you. That's that negative charge. The positive charge, the discharge, also elicits that small electromagnetic burst. So if we are out in a thunderstorm and the lightning is just traveling around in the cloud and it is staying just negatively charged up there, it's just going back and forth inside the clouds, negatively charged, it's not going to affect your EMF sensitive equipment, right? The moment that lightning touches down is when your REM pods, your paralights, those things will become more susceptible. So if you have a close lightning strike within like, even sometimes within like a couple miles, your equipment could technically light off, but it has to discharge. It has to become that positive charge to elicit that electromagnetic burst of radiation, right? But I digress from that even. The importance of knowing the positive and negative is that the negative is that buildup, that source, and the positive is that sort of end result from it. So if we are relating this, if we're putting on our tinfoil hats, if you've ever seen me on a podcast, you know what's coming. You know what's coming right now. All right. So we're now moving away from physics and we're going into tinfoil hat theories. So thinking about static. And it's the same thing, we're going to go back to that in a second when I start talking about equipment. if we're thinking about static, and we're thinking about static being created subatomically, it's with electrons, and we know that atoms are absolutely everywhere. It's in the air, it's in the water, it's in our clothes, it's in our bodies, it's in our hair, it's in everything. The air that I just blew out is a whole bunch of atoms pushing around atoms. Atoms are absolutely everywhere, which means that the electrons are also everywhere. Thank you. Oh, thanks. I know, I wanted to think of like some really funny analogies sometimes, but you know, there's only so much funniness you can do with physics. I mean, I'm going to be honest with you. I was just trying to relate it to things like farting, and I couldn't, so that's why. If it's not a fart joke, I don't want it. Okay. So, did you know that the tinfoil hat is something that is taken from the Faraday cage? That is why people think, that's why they wear tinfoil hats, because a Faraday cage blocks like radio waves from your devices, and it also blocks things like electrostatic discharge and things like that. So you'll see in big, huge, like labs and things like that that use huge like Tesla coils and stuff, they'll actually have like a discharge cage, and that's also a Faraday cage. So yeah, so we have our tinfoil hats on. Now, if we think about static being able to technically be created with all of the atoms that are around us, because all of those atoms have protons and neutrons, and they all have electrons, which means that they are all susceptible to have electron imbalances. And in order to create static, you need that friction. So you need something to be cutting down. You know where I'm going with this? This is where I get into like the idea that I feel like static could be present when either something is manifesting or something is being bzzz. If space-time is a tapestry, whoosh, cutting through it. I know sometimes that's a crazy thing to think about, but I hope people that like scroll by on Facebook just scroll by and they see this crazy lady with a tinfoil hat and they're like, what's going on here? But if we think about it in that way, if we really let our brains go crazy, the possibilities are endless with the presence of static in the paranormal in some capacity, because atoms are everywhere and we need to have that electron, you know, exchange to happen. So why not some sort of rip in space-time or some sort of culmination of energy to manifest itself? So the possibility of static in the paranormal is, I feel, almost like way more acceptable and plausible than even trying to find sources of EMF. Because also, I'm going to say because also 9,000 times, if we also consider the positive charge, that can result in a burst of EMF. So really, static could be a big answer to a lot of things, right? Because, you know, how do you know it works if you don't know how it works? Have you ever heard that one before? I have. And that is directly applied to taking your equipment out of the paranormal. And is it still testable? Is it still predictable? And are the results still repeatable? If your equipment can pass that test, if you can take it out of the paranormal and it is still testable, repeatable, and predictable, all three, then it is a piece of equipment that we can explain with science before applying it to the non-science of the paranormal. And I think that there is a lot of value in that. And I think that that will allow us to open up a lot of new doors in how we explore. More so than the phone apps that honestly we can explain the general idea, but they're not things that are testable, repeatable, and predictable. this piece of equipment does this, and look, this isn't a ghost, and this piece of equipment still does this. It's going to do this when this happens. That's what I mean by testable, predictable, and repeatable. It doesn't mean that I don't like communication. It just means that communication is subjective data, and it's not going to help prove or create any sort of compelling evidence. And there's nothing bad about that. But, you know, don't be afraid to scrutinize your equipment in order to add things to your exploration. And it definitely makes things much more interesting, as long as, again, it is testable, repeatable, and predictable. If you're not on the mailing list, please go to my store on my website, sign up for the mailing list. Not only is that the mailing list that I will send kind of first dibs for equipment to, including the brand new seer, the seer subname to be determined. But that is where I will send out the live classes that I'll do on Facebook, or maybe I'll do like a Facebook Live, YouTube Live kind of thing. So please go sign up for the mailing list. That's going to get you the sort of updates and the news and the appearances and all that stuff. But thank you for hanging out and sticking around, and thank you for the shares and the likes, and thank you so much for the comments. We almost hit like 100 comments. So I really, really appreciate like the cool engagement and the conversation. You guys are awesome. I hope this was fun. I will be posting the replay, so if you missed any of it, go back and you can watch me like stumble over my wipe-off board, lose my train of thought I think 3 times, and it'll be great fun. But until then, guys, be awesome, be kind to each other, in the name of the goose, Ray Gooseby, don't be a dick, and I love you so much. I will talk to you, I don't know, in another dimension.